Hey there, so today we're going to learn about the product of powers properties. We're going to move on with exponents. We're going to spend a couple days talking about exponent multiplication properties. So for our first day, we're learning what it means to have a product of powers. So all this means is you have two things that you're multiplying, and both things you're multiplying are going to have the same base, and your base is just the big number. So in this case, it's a 3 or 5 or a 2. So we're going to kind of write this out the long way just to see what's happening, and then we'll see if we can find a pattern to see what's happening when we do our product of powers. So the first thing we're doing here is 3 squared, which means 3 times 3. And then we're doing 3 to the third, which is 3 times 3 times 3. And notice here we're multiplying all of this together. Okay, so you're doing 3 squared, which is this part of it. You're doing 3 to the third, which is this part of it, and you're just multiplying all that together. So if we simplify what we just wrote, if you count them all up, notice you have 1, 2, 3, 4, 5 threes. So really, this is just 3 to the 5th. And now a lot of your answers are going to have large exponents, so you don't actually have to multiply out 3 times 3. We're not going to multiply all that out. We'll just kind of leave it as it is for these. We'll just kind of leave it as 3 to the 5th. Okay. For your next one, same thing. So we're going to do 5 squared, which is 5 times 5, times 5 to the first. But keep in mind, usually it won't say 5 to the first. It'll just say 5. They won't have like a first power with it. So this is 5 to the first, which is 1 5. And if you notice here, same thing. You have 2 of them here. You have just 1 of them there. So you have, here's your 2, there's your 1. You have 3 total 5s. So this would be 5 to the third. Okay. And your next one, same thing, write it all out. So you're doing 2 times 2. Then you're doing 5 of them. 2, 3, 4, 5. And then if you count them all out, you have 1, 2, 3, 4, 5, 6, 7 of them total. So then your exponent, and your final answer is going to be 2 to the 7th. Okay, and let me just, and I have the completed notes. I'm just going to double check to make sure that we don't have to multiply them out. Yeah, we'll just leave them as they are. Just leave them with the exponents. Okay, so let's see what pattern we can find. So this first one, it was 3 squared times 3 to the third, and our final answer was 3 to the 5th. We had 5 squared times 5 to the first, and our final answer was 5 to the third. Then lastly, 2 squared times 2 to the 5th, and our final answer was 2 to the 7th. So take a look at the 3 exponential expressions, which are these ones. In the middle column, we wrote them out. In the last column, we write the same expression, but with only one exponent. That's what that is. What we can do is we can use repeated multiplication. To rewrite a product of powers. These are products with powers. So rewrite a product of powers. All right, and then our little trick or a little shortcut, and this is what this little box is going to tell us right here, but we can see it in these problems that we just did, is if you notice, if you look at these exponents right here, you have a 2, you have a 3, and then your final answer has an exponent of a 5. This one you have a 2, and then this was a 1. So you have a 2 and a 1, and then your final answer was 3. And then this one you have a 2 and a 5, and your final answer was 7. So just think for a second, what are you doing with these exponents? What are you doing with 2 and 3 to get 5? Or 2 and 1 to get 3? What are you doing with 2 and 5 to get 7? Okay, so our little trick of what we can do is if you keep the base, notice the base stays the same. We don't change the base, but the base stays. All you do is you take your exponents and you just add them together, because this first expression has 2 3s. The second expression has 3 3s. So that means total, there's going to be 5 of them. You just add them together. So you just add 2 plus 3, and that gives you 3 to the 5th. There's your shortcut instead of writing it out every time. Okay, same thing here. You have 5 and then add 2 plus 1, add those exponents, and you now have 5 to the third. And then lastly, you have 2, add your 2 plus 5, and it's now 2 to the 7th. Okay, so all we do with product of powers is we just add our exponents together, and then that gives us our new exponent in our answer. Okay, so here's our little summary here. If you have a to the m times a to the n, as long as the base is the same, notice these are both a's right here. As long as the base are the same, to the same base. Okay, so when we're multiplying, so to multiply powers with the same base, we add the exponents. And that's why it's called a product of powers, because we're multiplying powers. So product just means multiply. Okay, so anytime they have the exact same base, again, they have to have the same base. But when they have the same base and when you're multiplying them, because it's a product of powers, you can just add up your exponents. Okay, all right, so for this first example right here, you have 15 squared times 15 to the third. You have 15 squared, you're adding 15, or no, you're adding your exponents, you're not adding 15 to the third. And if you want to, you can always do it like this and write it out. If you'd rather do it this way, I'm going to leave it like this. I'm going to do the shortcut, but I'm just going to start what gives you the same answer. So you have 2 15s with 15 squared. You have 3 15s with 15 to the third. Or your shortcut is just add your exponents. You now have 15 to the fifth. Check to see if there are any 0 or negative exponents, and there are not. So we know that we are done with our number 1. Okay, let's try number 2. So the base is the same. Keep it as a -4, but if your base is a negative, you've got to keep that, keep the parentheses with it, keep the negative with it. Okay, and then I've got -7 plus 2. That gives me -4. -7 plus 2 is -5. And then this one you're not done with yet because you have to fix this. You can't have exponents that are negative. So what this is, remember to turn it positive, you just put it underneath 1. So here would be your final answer, 1 over -4 to the 5th. All right. Go ahead and try these next 2. Go ahead and pause the video, try the next 2, and see what you get for numbers 3 and 4. All right, so for number 3, you're keeping this 0.3, and you don't really need the parentheses if as long as it's not negative, but you can keep them if you want to. And then I'm adding -3 plus -6. Okay. Now from here, I got I got 0.3 to the negative. This should be a 6. I was thinking ahead. -3 and -6 gives me -9. I can't keep it as a negative, so I got to move it to the bottom. So I have 1 over 0.3 to the 9th. Okay, and then number 4. This one does have negatives, so you do have to use your parentheses. If there is no exponent, there's always an exponent of 1. So let's put a little 1 here. Okay, and then you're doing 1 plus 5, which is -7 to the 6th. And again, as long as there are no negative or 0 exponents, you can just leave it as it is. You don't have to multiply all that out. All right, so let's try some that are a little bit trickier. So these next examples, you're doing the same thing. They're still product of powers because you have some powers and it's all products. It's all being multiplied, even within the expressions, even like the 5x to the 4th and the 4x to the 5th and 3y squared. Those are also still just being multiplied. I'm going to write it out just to kind of regroup things differently and then show you what our final answer is. So I'm going to rewrite this. I'm going to put all the coefficients up front. So the 5, the 4, the 3. And you're allowed to do this with multiplication. You're allowed to rearrange it in whatever order you want to. So I like to kind of color code it just so I'm keeping my numbers together. I'm keeping my x's together. And then I'm keeping my y's together. So I'm going to color code it So I keep my 5, 4, and 3. I'm going to keep that at the front. Then let's do alphabetical. So x comes before y. So I have x to the 4. I'll go ahead and just add it in this step. So I'm adding the exponents with my x's. I have a 4 and a 5. And then I have y squared. So again, I like to rearrange it and just kind of color code it so I know what I'm allowed to put together and what I'm not. Okay, I know 5 times 4 is 20, 2 times 3 is 6, so this would be 60. This is x to the 9th, y squared. Check for zeros as exponents and check for negative exponents. We don't have them, so we're all good for number 5. All right, let's try number 6. Again, I like to color code it just so I know exactly what I'm allowed to put together. So I can multiply the negative 2, the 12, and the 1/3. And then the x to the negative 2, I don't have anything to put with that. I have y to the 8 and y squared. Okay, and I like to rewrite it with all these coefficients in front. And then I have the x's, which is only one of them, and then I have my y's, which I have an 8 and a 2. So notice I'm taking the 8 and the 2 and I'm adding them together. All right, so let's see. I know 12, I'm doing this part of it here. Let's do the color coding again. Okay, so I know 12 divided by 3 is 4. And then 4 times negative 2 is going to give me negative 8. And keep in mind, you're more than welcome to use your Desmos calculator too, your 4-function calculator. And multiplying by a third is just dividing by 3. Okay, so that gives me the orange stuff, or the yellow stuff gives me negative 8. This stays as x to the negative 2. And then my y things are y to the 10th, because 8 plus 2 is 10. And then this one, you can't leave it like this because of this term right here, this x to the negative 2. You have to fix that. In order to fix it, remember, if the exponent is negative, you just move this down to the bottom. You put underneath this expression right here. But please leave this and leave this. You only put this down at the bottom. Okay, so my final answer, my x squared goes at the bottom, and it goes from a negative 2 to a positive 2 because I put it down at the bottom. And then up at the top, I leave my negative 8 and my y to the 10th. And I completely forgot a whole nother term, so that changes everything. All right, let's scoot this over and try this again. All right, I forgot this. I was zoomed in too much. I forgot this x to the 3rd. So I'm going to add that on. And then I got another term up front, but the x's are orange. Okay, let's try this again. I got a negative 3 to multiply again up here. That changes everything. Okay, so now what happens is the negative 3 and the 1/3 cancel each other out. So we got a negative 24. It's a long one. Your x term, so we did our coefficients. Now for the x term and then the y term. So for your x term, that's not negative anymore, so we don't have to flip it. Negative 2 plus 3 is just 1. So it's x to the first, but anytime if it's something to the first, you can just write that letter. You don't put to the first. And then we have y to the 10th. Well, that just made it a little bit easier because then you don't have to worry about flipping anything down to the bottom. All right, let's try that one. There we go. So number 6, final answer. Negative 24, x, y to the 10th. All right, go and take a look at, we're just going to do, let's do 7 and, well, let's skip 7. Let's do 8 and 9. So go and try number 8 and try number 9. See if you guys can do those ones. And then press play. Once you're done with them, just see what the correct answers are. Okay, so for number 8, you got some x's, you got a y, and while I'm color coding, I'll just go ahead and color code these. You got some constants, or some coefficients, you have x's, and you have y's. All right, so for 8, I'm going to add my exponents, or the exponents with my x. Okay, when I do that, -1 plus -8 is -9 y to the third. You cannot have a negative exponent, so we got to put it at the bottom. So here's my fraction bar. I have x to the 9th, and it is now positive because I put it at the bottom. And on top, I have y to the third. Okay. All right, and then number 9, last one we're going to do together is number 9. I always like to reorder it, so I'm going to do the 3 times 5 times 7 times x squared times y. And then I have -16 for this exponent and then 2 for that one. So I'm going to add them together. All right, so first thing I want to do is this multiplying stuff. 3 times 5 times 7. And I'm going to go to my calculator and just do 3 times 5 times 7 is 105. Okay, so I have 105 x squared y, and then when I do, here's the x stuff, here's the y stuff. When I do -16 plus 2, I know that's -14. You have to fix this. You cannot leave that with a negative exponent, so keep your 105 and keep your x squared. That stays. The only thing that goes at the bottom is the term or the variable that has a negative exponent. So that's the y to the 14th. All right, go ahead and fix that one if you did not have it correct. And then for number 7 and 10, I have these completed notes posted online, so on Canvas. So if you want to just take a look, and if you want to try them and then go to the notes on Canvas, you can do that. All right, last thing we're going to do is talk about multiplying with scientific notations. When you're multiplying with scientific notation, it's the same idea, because all of these problems on the left, these are all multiplication. Even when they look like this, it's still multiplication because the 4 is being multiplied by the y squared and the x is 7. So this is all, everything's being multiplied. It looks different, like it's chunked different. These are chunked together and these are chunked together. And then they use little multiplication signs like that in the middle. Scientific notation is the same, they just show multiplication a little bit differently. So we know it's being multiplied because you have this set of parentheses right next to this set. And then we also know it's being multiplied in here because of those multiplication signs. Okay, so you're still multiplying. You can rearrange it if you want to. I'll rearrange this first one, and then I'm not going to rearrange the rest of them. And then notice I did take this little note that we wrote last time on Scientific Notation Day, because you're going to have to pay attention. If the problem is in scientific notation, you have to keep it in scientific notation, which means that first number has to be bigger than 1 but smaller than 10. Okay, and a lot of these answers, you're not going to get that. All right, so I'm going to rewrite this first one. When I say rewrite it, I'm just going to rewrite the numbers in front. And then I'm going to put these at the back. So these are going up front because I'm going to have to multiply these together. I'm just kind of regrouping them. With multiplication, you can regroup them whatever order you want to. I know I'm about to do 10 to the third times 10 to the 5th. So there's that. You don't have to write that middle step right here, but this is me just showing you that I'm regrouping everything. I'm taking this yellow stuff and moving it to the front. I'm taking the 10, the base of 10 with the exponents and putting that at the end. Okay, now I'm going to multiply this, and feel free to use your calculator. So 3.72 times 2 gives me 7.44. And it's always nice when this number is already between 1 and 10, because now I know I'm not going to have to fix it. And then times 10. Remember when our exponents look like this, 10 to the third and 10 to the 5th, as long as the base is the same, you just add your exponents. So 3 plus 5 gives me 8. And this one, if you get negative exponents with scientific notation, you just leave it. You don't have to move it down to the bottom or anything. To turn it positive with scientific notation, go ahead and just leave it in scientific notation with the negative exponent. As long as this first number is bigger than 1 but smaller than 10. All right, let's try your next one. So for number 2, same thing. I'm just going to kind of multiply this without showing that middle step, but if you want to show the middle step, go ahead. So I'm going to do, I'll write it just so you can see. I'm going to do 8 times 2. And then it's 7 and negative 5 for my exponents. So I'm going to add them together. So here are my numbers. Here are my terms, or the numbers that have the basis of 10. I know 8 times 2 is 16. And then 7 plus negative 5 is 2. Okay, and if you want to, like we talked about before, if you aren't going to remember this rule that if you move the decimal to the left, you add to the exponent, or move the decimal to the right, you subtract, you can always just take this answer, write it out, and then turn it back into scientific notation. So if I have 16 times 10 squared, that's 16, and then move your decimal 2 times, so that's 2 zeros behind it. Okay, now I need to take that and move it into scientific notation. So my decimal's back here, move it 1, 2, 3 times, which really you're moving it 1 extra time than what it already was. So that's the adding 1 to the exponent if you move the decimal to the left, which is what we wrote at the top. So when you move the decimal to the left, you just add to the exponent however many times you moved your decimal. Okay, so my final answer is 1.6 times 10 to the third. All right, let's try one more scientific notation one together, and that's going to be number 4. If you want to try number 3 on your own, feel free. I have notes posted so you can see them. For number 4, you're squaring it. Okay, when you're squaring something, it means you're doing the same thing twice. So it's 6 times 10 to the third, and then 6 times 10 to the third. I'm going to rewrite this just so I know what I'm doing. These are together. These are together. So I'm about to do 6 times 6. And then 10 to the third times 10 to the third means I'm adding 3 plus 3. So whenever your base is the same, you add your exponents. Okay, so here's my yellow stuff. Here's my orange stuff. Okay, I know 6 times 6 is 36. And 3 plus 3 is 6. Again, if you want to remember your trick, go ahead, or just write it out. So if I write this out, let's see, I have 36, and then move your decimal 6 times. So 1, 2, 3, 4, 5, 6. That's me moving the decimal 1, 2, 3, 4, 5, 6 times. But then I want to move it back into scientific notation. So I got to move 1, 2, 3, 4, 5, 6, 7 times. Okay, notice I just moved it 1 extra time. That's the extra 1 that I add on to the 6 to move the decimal between the 3 and the 6. Okay, so my final answer, 3.6 times 10 to the 7th. There we go. All right, and I know we didn't get, we didn't get any of them with negative exponents, but keep in mind, if you do have a scientific notation problem that has a negative exponent, like 10 to the negative 8, or 10 to the negative third, just leave it as 10 to the negative. You can leave it as the negative exponent. Don't worry about moving it down at the bottom like we did with those ones. We don't have to do that with scientific notation. All right, great job. So feel free to try any of these problems that we didn't have a chance to get to, or if you were kind of stuck on one of them, rewind the video and rewatch that problem again. That way you can kind of clarify anything you're a little bit confused on. And again, I have these completed notes posted on Canvas if you want to try any of the problems again, or I might have them written a little bit differently on Canvas, just to help you see it just a different way. Okay, so again, feel free to watch whatever you need to, and message me if you have any questions.